So now we're going to move on to pointers. Everyone's generally used pointers. You probably use them in Java indirectly. So whenever you create a variable, it's sitting there somewhere in memory. Something is pointing to it. So what exactly are pointers? So what we're going to cover during this section is pointer variables and memory management. So C++ is really good when it comes to managing memory. So whenever you look at applications, say if you have a washer, dryer, a TV set, most applications that are on those particular chipsets are going to be created in C++ because you have limited memory, and C++ allows you to utilize that small amount of memory more effectively than other programming languages. So pointer definition, basically a pointer is a memory address of a variable. Whenever you create a variable, it's going to sit in a memory location. Every memory location has a memory address. So memory is basically divided into a number of memory locations and address used as a name for a variable. We use names for variables because they're easier for us to remember as developers. So imagine if you were to just use numbers, i.e. memory locations. Eventually that's going to get far more difficult for you to understand the logic of your code, especially if there's numbers. So generally everyone's used pointers already. Call by reference. Remember call by reference? And we will cover a bit of that. Call by reference is basically you're referring to the actual memory location of where that variable is, or where that data is stored in that variable. So you can manipulate or you could change the value of that memory location. Questions? Any questions? So pointers are typed. You can only store particular data items, a particular data type, based on what that pointer is. So I could say, I've got this pointer and I want this to point to just an integer type. So in that memory address, you can only store integer types. You cannot store anything else. So you can store pointer in a variable, not int double. So whenever you declare a pointer can only store a memory address. So how would you declare a pointer? So pointer in this case we have double, then we have an asterisk and a p. The p is the pointer, and the asterisk actually tells us that this is a pointer we're declaring, and the type we can actually store to whatever this pointer is going to point to is going to be of double. So p is declared a pointer to a double variable. So you can only hold pointers to a variable of type double, no other types. So once again, pointers are always declared by the asterisk before a variable name. So you'd have int, or the data type, asterisk, and the pointer name. You must you must use an asterisk before each variable. So let's have a look at this particular example. We have int asterisk p1 asterisk p2, then we have v1 v2. p1 and p2 are pointers because they have the asterisk. v1 and v2 are just normal int data types. That's all they store. They're just ordinary variables. So pointer is an address, is a memory address. An address in one form is an integer. So a memory address is an integer in one sort of aspect. But pointer is not an integer because it is a memory address. Does that make sense? So C++ forces pointers to be used as addresses, so you cannot be used as a number. So whenever you have an asterisk and a p, that tells you it's a memory address, and that's all you can store. You can point a particular pointer to a variable or a variable where that memory address is.
How does that make sense? The pointer is not an address,
And when we get to the coding, you'll understand it. And I've got some diagrams after that. So let's talk about, you've got a pointer and it's only going to point to a memory address, and the memory address is going to be a variable. So whenever you have a variable, you basically declare and you open a memory address, you open a cell that you can store a value in. So a pointer can only point to a memory location. So pointer variables point to an ordinary variable. Pointing terminology which is talking of pointing, not addresses. So you can say the address of a particular variable is stored in a pointer, but the terminology we're going to be using is it's pointing to. So pointer variable points to an ordinary variable. So generally we're going to use arrows to reference that. So let's have a look at this example here. And what you can do is I'll actually pause the video. Why don't you declare these variables, assign some values to it, and see what is output. What do you get as a C out? So I'll give you around 5 minutes to do that. So the operator ampersand actually determines the address of a variable, so address of a memory location. So the way this would generally be read would be P1 equals to the address of V1. So P1 is the pointer that's going to hold the memory address of V1, or P1 points to V1. So let's take a look at this example. So how do you think this would be read? So we've got int P1, P2. So we're declaring two pointers, which are P1 and P2, and then we're declaring two normal variables, which are int type. So what is P1 equals ampersand V1? How would you read that? What would the output be? Yes.
P1 points to the address of the integer V.
Well, you don't say the address of.
Okay.
You would just say P1 points to V1.
Address.
Which you're right, but P1 doesn't point to the address of it, points to V1. But it holds the address of V1.
Okay, so it points to V1.
Yes.
But it holds the address.
Exactly. That's what pointers only store memory addresses. That's all they store. So basically, the way you would read that is P1 points to V1. P1 points to V1. So you could say two ways to refer to V1 now are variable V1 itself. How do we access the value of what's in V1? We could say cout V1, that's what we normally do. Or you could say through a pointer. Because P1 already holds the value of V1 and it knows that it's pointed to V1, we can say cout asterisk P1. So that's kind of your dereferencing. That's dereferencing. So you're accessing the value of whatever P1 is by the pointer P1. So pointer variable is dereferenced, which means you get data that P1 points to. So why don't you try that? So to cout, so we'll assign a value into V1 and V2 or V1, then try doing cout V1 and cout asterisk P1. So I'll continue on that. Let's consider this. What what do you think is going to be output on this particular example? So we've got V1 equals 0, P1 is pointing to V1, then we're dereferencing, so asterisk P1 was saying whatever P1 is pointing to, we want to assign the number 42 into it. So what is it going to say? C out what? 42. And what about the next one? That should also be 42. So both of them are going to produce 42 because P1 points to V1. So we're kind of we're changing the value of V1 by the pointer. So we're saying whatever P1 points to, I want to assign the number 42 into that. So P1 and V1 refer to the same variable. So the ampersand operator is the address operator, also used to specify call by reference parameters. So whenever you're calling functions and you want to be able to access that one variable and change the data in that one variable, this is how you would do it. Otherwise, you'll just do a copy of a variable. There's by value and then there's by reference. By value allows you to copy or make a duplicate of that variable. Okay, let's look at this example. What is this doing? What do you think this is doing? So we've got pointer variables that can be assigned. So we've got int P1, P2 are both pointers. Then we got P2 equals P1. What is it doing? So you can assign one pointer to another. So you can make P2 points to wherever P1 points to. And don't confuse that with asterisk P1 equals asterisk P2. This is where you're assigning the values. You're assigning the values of whatever these pointers are pointing to. So here's an example. So here we've got P1 equals P2. So we've got before. So we're basically assigning 8 into whatever it's pointing to and 9 to whatever P2 is pointing to. So this is what we already covered. So whatever P2 is pointing to is 9. I want to assign 9 into whatever P1 is pointing to. So here we can actually point to as opposed to pointing to. So you can actually have two pointers point to one single element. So there is a slight difference between that. And you generally appreciate that when you get to other data structures like linked lists and so on. So the new operator, so earlier on I had mentioned that you don't need to have, or we don't need to declare variables by data types, what we're generally used to. We can actually create a new operator without an identifier like a variable name. We could just say new. So you could generally dynamically locate memory, and you can have pointers point to these nameless memory locations. So here's an example. So we've got P1, and assuming that P1 is a pointer, we've got P1 equals new int. So P1 will now point to this new memory location, nameless memory location, which is only going to store int data types. So we create a new nameless variable and assign P1 to point to it. So the only way to access what's stored in this new memory location is going to be with asterisk P1. So So it's not going to be we have to know the variable name. So we have to remember the pointer. So an example, and I'm just going to pause the video here. So take a moment to go through this code. I'll give you around 5 minutes. I'd like everyone to work in pairs on this, in pairs. So get together with another colleague next to you. So if we look at that previous code on that PowerPoint slideshow, so right at the top we have P1 and P1 and P2 are pointers. Then below that we declare a nameless memory location and we're pointing P1 to it. Then following that we're assigning the number 42 to whatever P1 is pointing to, so we're dereferencing it. Then we're saying whatever P2, I want P2 to point to whatever P1 is pointing to, so now they both point to the same memory location where we've stored 42 in this nameless memory location. Then the code says asterisk P2, so we're dereferencing. So whatever P2 is pointing to, I want to assign a new value into that, which is 53. And then I'll create another memory location, and I'm repointing P1 to this new memory location. And then following that, I'm reassigning or putting a new value into whatever P1 is pointing to. So now we have 2 pointers, each one of them point to 2 different nameless memory locations. Each of them have 88 and 53. Did that make sense? So we've covered this. We've covered a heap, which is free storage. So it's reserved for dynamically allocating variables. The operating system takes care of cleaning out these memory areas. So future new operations will fail if free store is full. So once again, if it does fail, you're unable to create a new memory location if you run out of memory. So that's why it's always a good idea to delete, and you can delete memory locations. So in the past, older compilers, you would check to see if there was sufficient memory or not. So this is in the older compilers, but you can actually do that. The new compilers, you use basically the new operation. If it fails, a program will automatically terminate rather than crashing and produces error messages. So it's good practice to use null. So whenever you declare a pointer, it's good to assign a null to it, generally, or if it's not pointing to anything. And I'm going to skip some of these, which is a free store, and get to the delete operator. So the delete operator is where you can actually delete a variable that you may have declared or a nameless memory location that you may have declared. So what we see here is we have int pointer, which is P. We're assigning, say, 5 to it, and we're pointing P into it. Then we do something here, then we say delete P. You may think delete P is actually deleting the pointer. It isn't, it's actually pointing whatever it's pointing to. It's deleting whatever it's pointing to. So the pointer is always going to stay there. So generally it destroys that memory location that pointer is pointing to.
What do you mean by destroy? Is it like randomly give it new numbers?
No, it removes it. It removes it.
Removes the value that was in it?
Yes, so it frees the memory address for other uses. So sometimes you have say multiple applications running on your machine. Sometimes memory is released, so these other applications can use it. If that memory was not used, there then you're going to run out of space eventually. So that's why your memory is always dynamic and changing. So delete P generally destroys dynamic memory, but P still points there. So what do we do? So in order for it to still point to a memory location that was deleted, which is known as a dangling pointer, we have to tell it, we have to get rid of that dangling pointer, so we have to set it to null. So P is then dereferenced. So if you try to access the value that P was pointing to, it's going to throw out a value that just doesn't exist in memory. So to do that, best thing to do is to set the pointer to null. Set it to null. Otherwise you get dangling pointers. So they're pointing all over the place. And as your applications become so huge, with millions and thousands of lines, so as developers it's difficult to keep track of what's pointing where. So it's good standard practice to set them to null. So summary, pointer is a memory address. It provides indirect reference to a variable. Dynamic variables, they can be created and destroyed. So remember the new and delete and setting the pointer to null. So those are the key steps that you need to remember. Yes?
I'm a little confused on that delete process. When you delete it, is it gone? And if it's gone, how do you assign the null value to it?